Hello and welcome. It's great to have you back. Today we are going to learn pandas. We are going to see what is pandas, what are names of different files that we can use with pandas. And then we'll look at what is series and how a series can be used to create a data frame. Later we then look at what are different ways in which we can view inside a data frame, sort it, transpose it, and finally we'll look at how we can convert a data frame into a Numpy array. And finally again we can look at what are the different descriptive statistics we can get for a particular data frame. This could be mean, max, quartiles, counts, etc. So here on the slide we see a table, and a data frame is exactly that. It's a table with couple of rows and columns. Each column in this particular table is a pandas series. So car make would be one series, the model would be one series, type would be another series. So it's a compilation of series that makes a data frame. And on this slide on the left I've listed a couple of names of file formats that can be used to import data into pandas. So most common is CSV, then we also have Excel, JSON, HDFS, SQL. And after we are done with data processing, and if we want to export the results or export processed data, we also have a choice of similar file formats in which we can export the data. So there is a wide variety of import export routes we can use to get the data in and get the data out after processing. Now let's go ahead and start working in Jupyter Notebook. First what we'll do is import Numpy and Pandas libraries. So I'm going to do that now. Import Numpy as np, import Pandas as pd, and let's create a series. So the format for creating series is similar to what we have seen previously while creating arrays. So let's see how we can do that. So pd.series, here open parenthesis, in square brackets we can write 1 2 3 4 and 1 3, and then we can print the type of x and x. So here as you can see, this is a pandas series and we can see the contents of the series right here. We can now use this exact series to create a data frame. And so to do that, the format is pd.dataframe with capital D and capital F, open parenthesis and open curly braces, because we are creating a dictionary inside. Here let's say column A is x, which is the series we created above, and we can go ahead and add another column B with additional elements such as 11, 12 and say 13. Now when we print the type of this df object, we can see that it would be a data frame, and we can print the data frame itself. So you can see that it's a class data frame, and we see two columns A and B listed here, and there is an additional column which is numeric, and that is index column for rows. So in pandas the data frames also begin with index 0. Now just as a flashback, in Numpy we created arrays in a similar format as we created series here, except for pd.series we had written np.array for creating arrays. Now let's add a few more records here so that we can use other commands to visualize a data frame. 1 2 13 45 66. I'm going to copy this and paste it, so we have at least 10 records. Let's do, and okay, So now we have that, and let's go ahead and add comma at the end of the list and add another column which would be let's say characters in them. So we can write A, B, C, and I'm going to copy these three. Let's create one more D, and copy these 3 times. Okay, so this should work, and it should give us a data frame. As we can see here, it has total of 12 elements with 3 columns. 2 columns are numeric and 1 column is character. Okay, so if we look at df.d types, we can see that the description of the columns, the C column is called an object. Now if we had a lot number of rows, say if we have 1,000 rows and we possibly don't want to view all those rows at once, so what we can do is look at the top 5 rows or top 5 bottom rows. To do that, we can use a head command, head and tail. So if we type df.head, open and close parentheses, we get the first 5 rows. Similarly, if we type df.tail, we get the bottom 5 rows, as you can see here. Now if we put a number within this parenthesis, we can change the number of rows that we can see. So if we put less than 5, say 3, we see 3 rows. If we say we put 9, in that case we see 9 rows of the data frame. Additionally, we can also look at the index. So here we see that the index starts from 0 and it goes up to 12, and it increases by 1. Okay, now let's see how we can convert a data frame into a NumPy array. So data frame to array, and to do that we simply have to write df dot to numpy, and we can put this in a different variable, say let's say x2. Now we look at the type of x2, print type x2, and we can print x2. So here, as you can see, we have converted the data frame into a NumPy array. And we can also look at the shape of the array now, since we have the data in array form, and we can see it's a 12 by 3 array. Now for data frame, if we want to look at the content, we can see that it's 36. So we are 12 into 3, total 36. And if you look at df.shape, we can see that it's a 12 by 3. So we have 12 rows and 3 columns in that particular data frame. Now if we want to transpose a data frame, how do we do that, and when do we need it? Sometimes we need to convert columns into rows just to access part of the data in that way. So doing that is easy. So let's create a data frame df2, and to transpose we simply say df.t. Now if we look at the data frame df2, we get all the rows converted into columns and the columns converted into rows. Here if we look at the df2.shape, we can see the column and row numbers have now switched. Okay, next thing we can look at, how do we get the descriptive statistics for Pandas data frame. So that to get that data information, we have to type df.describe, and that gives us the descriptive data, the numeric columns only. So we have count, mean, standard deviation, minimum, maximum, and we have the quartiles right here. And this is for columns A and B only, because those two columns are numeric, while other the third column C was not numeric, so therefore that column is ignored in this particular case. Now if you want to sort the values in a data frame, how do we do that? So for sorting the values, let's say we have this data frame right now. So I'm gonna pull just df.head and look at only 2 rows. So we have room here on the screen. Now if we want to sort the data frame by, let's say, index, then we can do that. So df.sort index axis is equal to 0. So we are going to use the column index, sorry, the row index. Why don't we look at everything here? So we are going to look at the row index, and we say ascending is equal to false. If we say ascending is equal to false, then the numbers that we will see on this particular screen will be decreasing. And as you can see here, they start at 11 and then they go down. Similarly, we can use another type of sorting. What if we want to sort the column by a particular by the values within a particular column? So let's pick the column B to sort this time. To do that, we would write df.sort underscore values by is equal to, here we have column B. Now this will sort everything by column B. Now by default it will be the smallest number on the top and it will be in ascending order, but here if you go ahead and say ascending is equal to false, then the sort order will become opposite and you have the larger number on the top. That's it for this video. In the next video, we'll talk about how we can use indices to access contents of data frames, and in videos after that, we'll dive deeper into other topics to understand how Pandas works and how we can leverage Pandas tools to work with data in projects. Please share, like and subscribe. If you have any comments, please post them below, and I'll see you all in the next video. Thank you.